In this video, we are going to see computer integrated manufacturing subject, in which the specialized topic is automatic flow lines. I am Rajakumar, Assistant Professor, Department of Mechanical Engineering, Rohini College of Engineering and Technology. In this topic, the automated flow lines in the manufacturing industries we are going to discuss. An automated flow lines consist of several machines or workstations which are linked together by work handling devices that transfer parts between the station. The transfer of work part occurs automatically and the workstation carry out their specialized functions. So the figure shows the red color symbol indicates the starting, that is a raw material. So enter into the first processing station. So each workstation, that is the processing automatically, that PROC indicate the processing, AUT indicate the automation. That is each and every workstation the product is partially completed into each and every workstation, then move into the next workstation. Finally the completed parts, the green color indicate means the parts is fully completed, that is a finished product. We get the finished product. That is the meaning of this automatic flow line. The figures shows the automatic flow lines. These automatic flow lines are designed to enhance the efficiency, consistency and speed in manufacturing. They involve the use of automated systems to manage and control the flow of materials and products through various stages of production. It is basically divided into two types depending upon the forms in which workflow can take place, as inline and U shape and L shape and rotary type. So different types of workstation is there. We will see one by one. Before that, we should know the objectives of the use of flow lines automations are to reduce the labor cost and to increase the production rate, to reduce work in progress and to minimize distance moved between operations, to achieve specialization of operation, to achieve integration of operation. Next, we are going to see the first type, the inline configuration. That is, the inline means in this figure shows the inline production flow lines involve a linear sequence of workstations arranged in a straight line. Materials or product move in a straight path from one workstation to the next, with each station perform a specified task. This is the figure shows the inline type. Next, segmental inline means the figure shows this is the L shape, that is a L shape configuration. Here the same working principle as in the inline configuration, but here the shape of the workstation in the forming in the L shape. Okay, so but the working principle are similar to the inline configuration, like that. Next figure shows the L shape configuration. Here also same, the figure configuration or figure that is a layout design is like U shape. That is a second step is a U shape, that is U shape layout. Here the same like that. First of all, the raw material enter into the first workstation, the partially completed machining operation, then move into the next workstation. So finally we get the completed parts out. Okay, that is the green color indicate the completed work part. Then rectangular shape configuration. Here the shape of the workstation in the rectangular shape. So then the characters of these all the shapes of configuration of the automated flow line means sequential process. In the product move linear through the each station where individual task or operation are performed. Then fixed layout, that the layout is typically fixed with the product flowing a predefined path. Then continuous flow ensure a steady uninterrupted flow of material or component through the production process. Then advantages of these flow lines means simplify the workflow, easy to understand and manage due to its straightforward linear layout. Then efficiency for high volume, that is ideal for high volume production of standardization product where the process is consistent. Easy integrations, it can be easily integrated with the automated conveyor system and robotics. So drawback of this system is limited flexibility, that is less adaptable to change in production design or production volume. Then bottleneck risk, that means slow down or issue at any station can affect the entire line. Example, the automotive assembly lines, that is a component are assembled in a sequence manner with each station adding a specific parts or performing a particular task. Electronic assembly, that is a components are assembled in a fixed sequence with each workstation handle a specific aspect of the assembly. Next, rotary type. The figure shows the rotary type. Here, rotary production lines involve a circular or rotary arrangements of workstations. Product or components are moved around a central rotating platform or table, which each workstation positioned around the circle to perform specific tasks as the product passes by this each and every workstation. Okay, so you can see this image. The first of all, the red color indicate there is a raw material. The raw material is entered into the each and every workstation in the circular manner. Okay, then finally we get the completed part in out. That is a symbol, green color indicate the finished product. Then characteristics of this rotary type is the circular motion product are moved in a circular path around a rotating platform or table. Stationary workstation, yes, the workstation remains in fixed position while the product move around them. Batch processing, often used for batch processing where product are processed in group rather than continuously. Then advantages means the compact design can be moved space efficient compared to this inline system, especially in environment with limited flow space. Reduced space requirements and increase throughout this allow the faster processing time for the certain operation due to continuous rotation. Then a disadvantage is complex setups and limited flexibility. Okay. Then example for this rotary type, so bottle filling, that is a rotary filling machines in the beverage industries. Then automated dialysis machines. Then in medical devices machine manufacturing, rotary systems can be used for the assembly of complex components. Then method of work part transport. The transfer mechanism of the automated flow lines must not only move the partially completed work parts or assembly between adjacent stations, it must also orient and locate the part in the correct position for processing at each station. The general method of transporting work pieces on flow lines can be classified into the following three categories. That is a 1. Continuous transfer, intermediate or synchronized transfer, then synchronized or power and free transfer. First of all, continuous transfer means the continuous method of transfer, the work parts are moved continuously at constant speed. This requires the workheads to move during processing in order to maintain continuous registration with the work part. For some types of operation, this movement of the workhead during processing is not feasible. It would be difficult. Then next name, that is a first of all we have to see in the continuous transfer. Next we have to going to intermediate or synchronized. Intermediate or synchronized means, as the name suggests, in the method of workpiece are transported within the intermediate or discontinuous motion. The work parts are fixed in position and the parts are moved between the station and the registered at the proper location for processing. All work parts are transported at the same time, and for this reason the term synchronized transfer system is also used to describe this method of work part transport. The synchronized transfer means This system of transfer, also referred to as a power and free system, allow each work parts to move to the next station. When processing at the current station has been completed, each part move independently of the parts. Hence, some parts are being processed on the line at the same time that others are being transported between stations. Thank you.